In 1990, NASA's Galileo spacecraft detected unmistakable signs of an industrial civilization from 600 million miles away. The chemical signature included chlorofluorocarbons, manufactured pollutants that could only have been produced by technology, and the source of this contamination turned out to be Earth itself. That experiment took years of convincing NASA and the Jet Propulsion Laboratory to conduct, and what it revealed about our planet changed everything. The instruments pointed outward in search of cosmic intelligence. But the most unsettling discovery turned out to be ourselves. What we learned about Earth from that distant vantage point continues to haunt the scientific community, not because the experiment failed, but because it succeeded and exposed just how fragile, how detectable, and how endangered our civilization has become. The concept emerged from a simple question that kept coming up at Cornell's Laboratory for Planetary Studies. If an extraterrestrial spacecraft flew past Earth, knowing nothing about our world, could it determine that something extraordinary was happening here? We had been searching for signals from other civilizations and scanning the heavens with radio telescopes while imagining what alien technology might look like. Yet we had never performed the most basic experiment of all. Nobody had examined our own planet the way we examine others, as an unknown world to be studied with fresh instruments and no assumptions. Galileo was already on its way to Jupiter and would use Earth's gravity to slingshot toward the outer solar system. The argument for turning its cameras and spectrometers toward home during this flyby gained traction slowly, and the idea was to pretend we were visitors from another star system encountering this blue world for the first time. No assumptions, no prior knowledge, just the raw data. The first thing that would strike any careful extraterrestrial scientist is our atmosphere, because Earth's atmosphere exists in a state that is wildly and impossibly out of chemical equilibrium. That phrase sounds technical, but its implications changed how we think about searching for life beyond our world. On a dead planet, atmospheric gases eventually settle into stability and reach a kind of chemical peace. Mars has an atmosphere that is 95% carbon dioxide, and Venus shows the same pattern, both representing atmospheres in equilibrium where nothing actively changes them. Earth tells a different story entirely. We have 21% oxygen and significant methane existing side by side, which makes no chemical sense because oxygen and methane react with each other and should destroy one another over geological time. The only possible explanation for their coexistence in these quantities is that something continuously pumps both gases into the atmosphere, actively working against chemistry itself. That something is life. Plants and cyanobacteria pour oxygen into the air through photosynthesis, while microbes in wetlands and in the digestive systems of animals release methane. The very existence of this impossible atmosphere functions as a beacon, a signal detectable across interstellar distances announcing that Earth is not a dead world. Our planet has been advertising the presence of life for billions of years to anyone with instruments sensitive enough to notice. The search that consumed much of this career now had a template, and when telescopes become powerful enough to analyze the atmospheres of planets orbiting distant stars, we know exactly what to look for. NASA's James Webb Space Telescope has already begun this work, searching for atmospheres in chemical disequilibrium, atmospheres that should not exist, atmospheres that shout across the light years that something is alive. Life does not passively exist on a planet, but transforms its world and reaches up to rewrite the chemistry of the sky, which means every breath you take connects you to 4 billion years of biological chemistry actively reshaping this planet. The Galileo experiment revealed something even more startling beyond the oxygen and methane. The instruments detected another class of molecules in Earth's atmosphere called chlorofluorocarbons, industrial refrigerants and propellants that do not occur naturally. No biological process produces them in detectable quantities, and no geological process creates them, which meant they could only have been manufactured by a technological civilization 600 million miles away. An alien observer could determine not merely that Earth harbors life, but that Earth harbors industry, technology, and minds that have learned to manipulate matter and reshape their environment. The signature of our civilization is written in the very air we breathe, and that realization led to something unsettling that connects to the broader search for extraterrestrial intelligence. Earth has been leaking information about itself into the cosmos for billions of years. First, through its impossible atmosphere, and now through radio waves, television signals, and industrial chemical signatures. Any civilization with sufficient technology could have detected us long before we knew to look for them, which means we are not hidden and have never been hidden. The data from that experiment produced two simultaneous feelings. The first was wonder, pure and overwhelming wonder at what we had proven about life and technological civilization, leaving unmistakable fingerprints on a planet. The book Cosmos could only speculate about detecting biosignatures on distant worlds, but now we had demonstrated it was possible, and the universe might be less lonely than we feared. The second feeling was dread, because those same instruments revealed something else about Earth that keeps any thinking person awake at night. The data showed evidence of massive environmental modification, not just the CFCs that we already knew were tearing a hole in the ozone layer that shields all life from deadly ultraviolet radiation. The signatures indicated widespread deforestation, agricultural transformation of entire continents, and carbon dioxide accumulating in the atmosphere at rates unprecedented in the geological record. A hypothetical alien observer examining Earth with dispassionate scientific instruments would reach an inescapable conclusion. This world is inhabited by a technological species that is systematically altering the very conditions that make its own existence possible. A species conducting an uncontrolled experiment on its only home. Another experiment from years earlier connects to this discovery and haunts the scientific record still. Doctoral research at the University of Chicago focused on the planet Venus, which serves as Earth's twin in many ways, with similar size, similar mass, and a comparable orbital distance from the Sunday. The ancients imagined Venus as a paradise with tropical forests and gentle rains hidden beneath its eternal clouds. But what we discovered instead was an inferno. The surface temperature of Venus reaches nearly 900 degrees Fahrenheit, hot enough to melt lead. And the reason for this hellscape is straightforward physics called a runaway greenhouse effect. The Venusian atmosphere consists almost entirely of carbon dioxide. So sunlight penetrates the clouds, but the heat cannot escape, trapping the planet in an endless fever from which there is no recovery. The first calculations of Venus's surface temperature from basic radiative physics drew skepticism from colleagues because the numbers seemed too extreme. The greenhouse properties of carbon dioxide had been understood since the work of Svante Arrhenius in the 19th century, but applying them to Venus produced results that seemed impossible. Spacecraft sent there confirmed the calculations exactly, and Venus became a cautionary tale written in fire across the morning sky. A strange truth emerges from studying that hellish world. Venus gave us the very physics we need to save ourselves, because the planet that demonstrates the greenhouse effect in its most extreme form also handed us the equations to predict and potentially prevent our own warming. The haunting question is whether we will use that knowledge. The physics that makes Venus a furnace operates identically to the physics that governs Earth, with carbon dioxide trapping infrared radiation here exactly as it does there. We are pumping carbon dioxide into our atmosphere at an extraordinary rate by burning ancient forests, burning coal and oil and natural gas, and releasing carbon that was sequestered underground for hundreds of millions of years. The carbon dioxide content of Earth's atmosphere has increased by over 40% since the Industrial Revolution, and the concentration continues rising year after year and decade after decade. Congressional testimony from James Hansen about these dangers presented the same fundamental physics studied on Venus, now applied to our own world, and the warnings could not have been clearer. Earth will not become Venus because our situations differ enough that a full runaway greenhouse effect is not our immediate fate. That distinction misses the point entirely. We are altering the climate that has supported human civilization for 10,000 years, a stable and benevolent climate within which we invented agriculture, built cities, developed written language, and created everything we call civilization. The atmospheric composition of our only home is changing without our full understanding of the consequences. Ice sheets are diminishing and sea levels are rising, while weather patterns shift in ways that will affect billions of people. The climate that allowed human flourishing is changing, and we are the cause. We are doing this with full knowledge, which disturbs any careful observer most deeply. We are not ignorant, and we have the science, but we have not summoned the collective will to act on what we know. One more discovery from research conducted with colleagues in the early 1980s revealed how profoundly we had miscalculated the mathematics of our own destruction. The world at that time was armed with tens of thousands of nuclear weapons, and the United States and Soviet Union had accumulated arsenals capable of destroying civilization many times over. Military strategists operated under a doctrine called mutual assured destruction, the grim logic that neither side would launch a first strike because both nations would be annihilated in the response, creating a terrible equilibrium. The question that strategists had never asked was simple. What happens to Earth's atmosphere if even a fraction of these weapons detonate over cities? The calculations revealed nuclear winter. Nuclear explosions over urban and industrial targets would inject enormous quantities of soot and smoke into the upper atmosphere, and this debris would spread around the globe within weeks to block sunlight. Earth would be plunged into darkness for months or possibly years. Temperatures would collapse, and crops would fail on every continent. Survivors of the initial exchange would face a frozen and darkened world, unable to grow food, unable to find uncontaminated water, and unable to sustain the complex systems that modern civilization requires. The published findings became known as TTAPs, after the author's initials, and the scientific community examined the models while challenging assumptions and running independent calculations. Debates continued for years as they should in science, but the fundamental insight proved robust. Nuclear war would not merely devastate the nations that fought it, because nuclear winter would threaten all of humanity. Missiles launched from North America and the Soviet Union would devastate Africa, South America, Indonesia, India, Australia, and every nation that had sought only to live in peace. No country could escape the atmospheric consequences of a war fought by others. This discovery changed more than science because it changed the mathematics of war itself. Strategists had assumed that a sufficiently powerful first strike might succeed, that a nation might win a nuclear exchange if it struck hard enough and fast enough. Nuclear winter demolished that calculus completely. Even a successful first strike would destroy the attacker through climate collapse, which meant there could be no winner. The game theory of nuclear conflict had been calculated incorrectly for decades. A species intelligent enough to unlock the energy of the atom, send machines to other planets, and deduce the age of the universe had built the instruments of its own extinction without understanding what they would do to the atmosphere we breathe. The machinery of global annihilation existed for years before anyone thought to calculate the climate consequences. This pattern connects all three discoveries: the Galileo experiment, the Venus greenhouse, and the nuclear winter study. We are a young technological species that has possessed the power to fundamentally alter our planet for barely a century. A geological instant, a single tick of the cosmic clock. Within that instant, we have developed multiple capabilities to render Earth uninhabitable through nuclear war, through climate disruption, and through technologies we have not yet invented, but surely will. We have accumulated godlike powers without developing the wisdom to wield them responsibly. The photograph that Ann Druyan spent years advocating for captures this reality completely. Voyager 1 took that picture as it departed the solar system for interstellar space, turning its camera around for one last glimpse of home after arguments with NASA administrators who thought it a waste of spacecraft resources. Many questioned what scientific value such an image could have. That picture contained everything. Earth seen from 4 billion miles away appears as a fraction of a single pixel, a tiny point of pale blue light caught in a scattered ray of sunlight. From that distance, all the divisions that seem so important from the surface vanish into a dot smaller than a grain of sand held at arm's length. All the nations and borders, all the wars and conflicts, all the grand ambitions and petty grievances disappear into that single point of light. Return to the hypothetical extraterrestrial observer for a moment. They have detected our oxygen atmosphere from light years away, analyzed our industrial chemical signatures, and noted our radio emissions bleeding into space. Now, they turn their most powerful telescope toward this small blue world and resolve it as a single point of light. Their conclusions about the beings inhabiting that pale dot would be sobering. They would see a world of liquid water, which is rare in the cosmos. They would detect an atmosphere maintained by life itself, which is rarer still. They would find evidence of a technological species, which might be the rarest thing of all. And they would observe that this species appears to be systematically degrading the very conditions that permit its existence. Every human being who has ever existed lived on that dot, and every act of kindness and cruelty, every moment of love and hatred, every war fought and peace negotiated, happened there on a mote of light in the cosmic darkness. The dinosaurs ruled this planet for 160 million years with magnificent success, adapted to every environment and diversified into countless forms. 65 million years ago, an asteroid struck what is now the Gulf of Mexico, and in a geological instant, they were erased. All that evolutionary achievement and all those millions of years of adaptation disappeared. They never saw it coming because they had no telescopes, no understanding of orbital mechanics, and no technology to deflect the rock that destroyed them. They were helpless before the random violence of the cosmos. We are not helpless, and that difference matters more than anything else. We can see the asteroid coming. We understand the greenhouse effect, and we can model nuclear winter. For the first time in 4 billion years of life on Earth, a species exists that can comprehend the threats it faces and potentially do something about them. Evidence shows we can respond when the science becomes clear enough. The same CFCs that Galileo detected from 600 million miles away no longer fill our atmosphere because we banned them. The Montreal Protocol, signed by nations around the world, phased out the chemicals that were destroying our ozone layer, and the ozone hole is healing now with full recovery expected within decades. We saw a planetary threat, we understood the science, and we acted together. Nuclear arsenals remain terrifyingly large, but have been reduced from their Cold War peaks. The nuclear winter research contributed to a shift in thinking, a recognition that these weapons could not be used without planetary consequences. Treaties were signed. and weapons were dismantled. The clock has not struck midnight. This tells us something important about ourselves. We are capable of responding to existential threats when we choose to, and we are not prisoners of our worst impulses. The same intelligence that created these dangers can address them if we decide to act. We are the local embodiment of a cosmos grown to self-awareness, having begun to contemplate our origins, study the stars that forge the atoms in our bodies, and send our instruments and questions into the void. We are a way for the universe to know itself. What we do with that knowledge on this single fragile world will echo through the ages. We might become the species that matured in time, recognized its planetary boundaries, and chose wisdom over short-term gain. We might spread life and consciousness beyond this one vulnerable world, ensuring that even if Earth someday faces a catastrophe we cannot prevent, the story of life continues elsewhere. We might also join the long list of evolutionary experiments that did not persist. Species far older than ours have vanished utterly, and worlds that once held promise have become sterile wastelands. The universe does not owe us survival, because extinction is the rule, while continuation is the exception that must be earned. Earth remains the only world known so far to harbor life, and there is nowhere else in the foreseeable future to which our species could migrate. Visiting other worlds has already begun, but settling and making a home remains generations away at best. For now, for our children and grandchildren and great-grandchildren, Earth is where we make our stand. That pale blue dot, that pixel of light in the cosmic darkness, is everything. It is the cradle of every human who has ever lived and everyone who will live for generations to come. It holds all our art and science, all our love and memory, all our potential for greatness and our capacity for folly. The experiments conducted on Earth revealed not that our planet is large and permanent and invulnerable. They revealed the opposite. Earth is small beyond comprehension when viewed against the scale of the cosmos, fragile in ways we are only beginning to understand, and alone in a universe that is largely hostile to life as we know it. Whether Earth remains a haven for life and mind, or becomes another silent world orbiting an indifferent star, that choice belongs to us, to this generation, to everyone alive right now who can understand these words. We are star stuff that has learned to contemplate the stars, matter that has awakened to ask questions about itself. We have been given the rarest gift the universe can offer, which is the ability to understand our situation and choose our response. The dangers themselves are not what haunt the scientific record, because studying dangers has been the work of a lifetime. What haunts us is the knowledge that we possess everything we need to face these challenges, combined with uncertainty about whether we will find the collective will to do so. The cosmos will not wait for us to decide. The physics of our atmosphere operates whether we acknowledge it or not. The weapons we have built remain ready for use, and the climate continues to shift. We have seen what humanity can accomplish when we work together. Having sent machines to the outer reaches of the solar system, gathered knowledge no generation before us could have imagined, and glimpsed our cosmic address with eyes finally open to its meaning. The choice remains before us, as it has always been before us, and everything depends on what we decide.